In this video, I want to briefly discuss the contactor system and the adductor nozzles that feed into the contactor. So the main pump flows in a loop by injecting liquid into the top of each of the three adductors installed on the top of the contactor. That liquid is then drawn back to the inlet of the main pump. There are several other loops that pull off the contactor, including the aeration loop and the filtration loop. And that's what you see these lines up here. The top loop is the slurry line that feeds to the centrifuge. The middle loop is the regeneration loop that feeds to the aerator, vessel 2030. Those loops get returned back to the contactor, but the point of this right now is to discuss the adductors. So liquid is pumped into the top of the adductor, and that draws in gas by the process of adduction, creates a low pressure pocket and draws the gas in. In this case, the customer is providing it at 47 inches of water already, so it's pushing it in, but the gas is also being drawn in. Now, you should commonly see a stair step across the three stages of the contactor. The contactor has a liquid level that should be maintained above 50%, and it has weirs, internal walls from the ceiling dropping down, not all the way to the bottom, but about halfway down at about the 50% point. And so as each adductor draws its gas in, it mixes together in this pocket, and then it's drawn in by the second adductor, and then mixes into the second pocket and is drawn in by the third adductor. So as each successive adductor operation occurs, the pressure builds. In this case, 47 inches of water to 52, almost 53, then up to 59, and then to 64 on the way out. So as that increase in pressure occurs, you're going to see the liquid level get pushed down deeper and deeper. Now, these are all in communication at the bottom, so that's why the liquid level is allowed to drop like that. It forces more liquid to the lowest pressure region of the system, which is the first chamber. So if you drop the liquid level below 50%, and in this case the third chamber, it's okay, but in the middle in the first chamber, if you drop the liquid level below 50%, the gases, when they're drawn in by the first adductor, are going to simply slip under that weir wall and skip the entire process and potentially shoot all the way to the end and out the system, and you'll have high outlet ppm. So it's important to maintain an appropriate liquid level above 50%. And you can't go above about 70%, because then this first chamber liquid level will raise all the way to the top as it builds pressure and pushes liquid in, and it will interfere with operation of the adductor. So the contactor has a narrow band that it needs to maintain, and it's because of this common stair-step profile across the contactor. Additionally, the radar and the third pressure reading are taken at approximately the same location. So these two should be in very close agreement. If they're not, the radar typically will be indicating foaming in the system. Right now, it's simply a few percentage points below the active reading. This is effectively the same value. Now, if we have heavy foaming, the radar can be upwards of 80, 90, even 100%, indicating that foaming is carrying over and exiting it out of the unit. Each adductor and the pressure increase across it is dependent upon the initial conditions of the gas flow going into it. So it's difficult to say how much each one should be increasing. But the third stage adductor, the pressure on the third stage adductor, can be directly affected by the gas valve 1050. In this case, it's 40% closed. The gas draws into the unit, works its way through the contactor, and out. If I open this valve fully, it will allow for greater gas flow, but then the third adductor is going to do less work, and it's not going to have any pressure built up against it, depending upon the conditions of your plant on the outlet gas stream. But that's going to affect this final pressure reading and can make it even the same as the middle pressure reading, as it doesn't have the ability to build any pressure. Typically, we have this valve pinched back 60 to even as low as 30%, depending upon gas conditions of the system. A sign that these adductors need to get cleaned or unplugged will be under normal operating conditions with PCV 1050 pinched at least 50% and pressure remaining the same across each adductor, or the same across the first two, with sufficient liquid level such that it doesn't slip under. In this case, I have plenty of liquid level. If I notice that these values were the same across each adductor, it's very likely that there's a plug, and they will need to be removed and cleaned.